In this video, I'll be going over even and odd functions. We say that a function is even if the function f of x is equal to f of negative x. Graphically, what this means, the function is symmetrical about the y-axis. So, for example, if we have this function, it's a parabola with a vertical shift. This is symmetrical about the y-axis. All right, on the other side we have an odd function. And we say a function is odd if f of negative x is equal to negative of f of x. And graphically, a function is odd if it's symmetrical about the line y equals x, which is sometimes called the origin. Okay, so an example of a function that is odd could be something like that. So we'd say that this is symmetrical about the origin. Okay, so what we want to be able to do is, if we're given a function, determine if the function is even, if the function is odd, or in many cases the function will be neither even nor odd. So let's look at a few examples. Determine algebraically if the function is even, odd, or neither even nor odd. So first of all, we want to check algebraically, and looking back, we want to test both of these instances. And, well, maybe not both, because if we test the first instance and the function is even, we're done. The function cannot be both even and odd. But we'll test these algebraically, and there are three possible outcomes. The function can be even, odd, or neither even nor odd. So let's look at our first one. F of x is equal to x cubed minus 4x. So what we do is, first let's test for even. So if a function is even, f of x is equal to f of negative x. All right, so we already have f of x over here. So is that equal to, is that equal to f of negative x? So let's find f of negative x, and all we do is we input negative x into the input of the function. And what we get is, well, negative to an odd exponent is going to be a negative, so negative x cubed. Negative times a negative is positive. Okay, so the question is that equal to our original function? And those are not equal. So we'd say not equal, so this function is not even. Okay, then let's test for the function being odd. We're going to say f, or negative f of x, is that equal to f of negative x? Well, we already have f of negative x. It was this right here. Okay, so that is negative x cubed plus 4x. So what we need to do is find negative f of x. So what we do is we say negative times the original f of x function. So negative of x cubed minus 4x. Distribute the negative x cubed plus 4x, and that is equal to f of negative x, so that is equal. So we'd say is this function is odd. All right, now again, when we say determine algebraically, this is what we need to do. We actually need to go through this test. All right, our second function, g of x is equal to x squared plus 5. Let's see if this is even first. So f of x, well, our function is g, so let's say g of x, is that equal to g of negative x? Well, g of x is x squared plus 5. Is that equal to g of negative x? So I'm going to put a negative in for x, and we end up with x squared plus 5, and that is, in fact, equal to our original function. So we'd say that g of x is even. And once we know that the function is even, there's no other work. for us to do. All right, and then the third one, h of x is equal to 3x squared plus 2x. Again, let's test for the function being even first. Is h of x equal to h of negative x? Well, we already have h of x. Is that equal to h of negative x? So 3 times negative x squared over 2 times negative x. So we end up with 3 negative x times negative x is x squared divided by negative 2x. Okay, so those are not equal, so we'd say not even. All right, so let's test for odd. H of negative x, is that equal to negative h of x? All right, we already have h of negative x. It's this down here. So 3x squared divided by negative 2x. Is that equal to negative of h squared? So this is going to be negative of 3x squared divided by 2x. Like this. So the question is, are these equal to each other? And the answer is yes. When we have a fraction, if there is a single negative sign either in the numerator, the denominator, or in front of the fraction, those are all equal to each other. So these are equal, so we'd say that this function is odd. So that's a wrap. That's how we find even and odd functions algebraically.